Hi guys, and welcome back to our video. I'll be showing you the answer to the second in-class assignment. So let's start off by creating an object called long.sequence. And you can name it whatever you want. That's just the name that I'm going to use. So I'm going to create an object called long.sequence. And then I'm going to use the rep function. And then I'm going to type sequence. And I want a sequence from 10 to 100. And I want to be this sequence to be at intervals of 5. And then I want to repeat this sequence 8 different times, right? So my question earlier was, how would you code 8 sequences of 10 to 100 at intervals of 5? So to answer that question, first you have to create one sequence from 10 to 100 at an interval of 5. Which is done right here. And then you want to repeat that sequence 8 different times. So again, work in, out. So we first create one sequence from 10 to 100 at intervals of 5, and then we're going to repeat that function 8 different times. So if I run that line of code and then let's take a look at it. Okay, have to run it. We find that we have a very long sequence. It's over 130 different unique elements. And it looks like they're ranging from 10, 15, 20, 25, 30. That's going to go all the way to 100. Then it's going to repeat again, 10, 15, 20, all the way to 100. And then we're going to do this 8 different times. I'm not sure exactly how many unique elements are in there. I guess it should be... I'm not exactly sure, but in order to, if you want to find the length of a given vector, so how many unique elements are in a vector, use the length function. So I'm going to use the length function, and then I want to find the length of long sequence because I'm not really sure how many unique elements are in this sequence called long sequence. So on line 82, we're going to use the length function and then run that. And we find that the length of long.sequence is equal to 152. So we actually have an object that's a vector of 152 unique elements. So that's pretty long. And hopefully you guys were able to find that answer. But if not, it's okay. Just keep following along with these answers, and I'm sure you'll learn a lot along the way. So now we're going to move on to the next section in the course, which is types of data sets. And we're going to work with matrices, data frames, and lists. So let's start by creating a matrix. So what is a matrix? Maybe you guys have taken other mathematical courses and you're familiar with a matrix, but a matrix is essentially kind of this gridded data set where you have a series of different columns and you have a series of different rows, and then you're storing values within this data set. And they can be very long and complicated, but we'll be working with a couple of simpler ones in these examples. So let's start off by creating an object called mat.data. So it'll be standing for matrix data. And then I want to create a matrix. So I'm going to use the matrix function, which helps us create matrices. And then I'm going to start off with the first argument, which is data equals. And I actually want to use all of the data that are going to be in this matrix are going to come from this in-class assignment that we worked with from a long sequence. So the data in the matrix is equal to long sequence. The number of rows in the data set are going to be 19. Because within one sequence from 10 to 100 at intervals of 5, those are going to be, I think there's 19 different unique elements from 10 to 100 at intervals of 5. So we want 19 different rows, and then the number of columns is going to be equal to 8 because we repeated that sequence 8 different times. And so you can have matrices that are populated either by columns, or you can populate matrices by rows. So we want to actually populate our matrix by columns. So we're going to set this by row element argument, and we're going to set it equal to false because we want to populate our matrix by columns. So just in synopsis here, we're creating a matrix. The data within the matrix is going to be equal to the values in long sequence. We want the matrix to have 19 different rows because that's how many elements are in one of these sequences. And then we want to have 8 different columns because we repeated each sequence 8 different times. And then we want to populate the matrix by column. So we set the by row element argument equal to false. And if I run line 89, and then I can type out mat.data, we look in our console and we have a matrix that's equal to the data in a long sequence. We have 8 different columns. We have 19 different rows. So, and the values are at that 5 numeric interval where we're going from 10, 15, 20, 25, 30, and that sequence is repeated 8 different times in all of the different columns. So we have successfully created our matrix. And another way we can look at the data, in addition to looking at it in the console, is that we can use this view function. So let's say we type out view, and then we click mat.data, and then we run line 91. We see that a new window opens up kind of in our R script, and we have all of the different values that were in mat.data. So this is just another example of how you can view data in R. We can look at it in the console, but we can also look at it by using this view function. So I typed view, and then I typed in the data set that I wanted to look at, and it opened up this new window for mat.data. And now I think we'll be moving on to another example. So we created a matrix from long sequence, but let's create a matrix where we were working with the grades from the 3 classes that we created earlier on in this course. So let's create an object called grade.matrix, and we'll set it equal to a matrix constituted by data from all.grades. Again, all.grades was the object that was constituted by class.1, class.2, and class.3. And the number of rows in this matrix is going to be equal to the length of all grades divided by 3. Okay, so that's a little bit of a complicated argument. Hopefully you guys are able to follow. So how many rows are going to be in this matrix? Well, each class, I believe, had 10 different students. So all grades should be equal to 30 unique elements. And I want each column to represent all of the classes in each grade. So if I find the length of all grades, which should be 30, and then I divide it by 3 because there's 3 different classes, we should get a value of 10, which is what I intended, because this matrix is going to be, in column 1 is going to be class 1, column 2 is going to be class 2, and column 3 is going to be all the grades in class 3. So because we have 10 different grades in each class, our n row argument, so the number of rows, is going to be equal to 10. And maybe you guys noticed earlier, but I actually, I clicked enter, which brought this parentheses down to line 94. So when you're writing code in R on line 93, I could go all the way horizontally and keep typing arguments farther and farther to the right, but sometimes that can get very difficult to view. So something that is very common in R script is that you can actually just click enter, and you can continue writing your code on the subsequent line with the same function. So sometimes that's a little bit easier to work vertically as opposed to horizontally. So our number of rows is equal to 10, and then the number of columns, the nCol argument, we're going to set that equal to 3 because we have 3 separate classes. And then our by row argument, we're going to set to false because we want to populate this matrix by columns. So let's say I run line 93, and then I can take a look at grade.matrix, and looks like we have three columns for our 3 separate classes. The grades are kind of in the 70s and 80s and 90s. So I believe that the mean of class 1 was an 80, class 2 I think it was a 70, and class 3 was a 90. Those grades look appropriate. I think we rounded only in classes 2 and 3, and we didn't round in class 1. So all those data make sense, and I'll just use this view function, which I showed earlier, which is just another way of looking at a data set. And if I run that line, we can look at grade.matrix in this new window, which is sometimes a little bit easier for me. I think I prefer looking at the data in this window, and just another example of how you can view data in R.